Okay, starting at 17, simplify, and this is an attempt at a multiple choice verification problem. So cosecant, turn it into sine or cosine. Well, that would be 1 over sine. Sine, there's a couple different ways you could go about this. You could use the difference formula, or you could see that this is equal to cosine. That is also on your identity sheet. Either way, it does simplify to cotangent. Use our sum or difference formula to find the exact value. This is the problem where you have to, if we want pi over 12, we're going to have to do sum or difference to find two things that add or subtract together that equal pi over 12. So in this case, he chose 4 pi over 12 and 3 pi over 12. They subtract to give me pi over 12. Well, 4 pi over 12 is a unit circle thing. That's pi over 3. 3 pi over 12 is a unit circle thing. That's pi over 4. Plug it in, multiply, and you get an answer. Multiply and then add. 19. Find the exact value of sine 2 theta if cosine equals that. That means draw a unit circle. It tells you what quadrant you're in. Between 90 and 180 is quadrant 2. Use the Pythagorean theorem to find the missing side. Plug it into the formula. So 2 times sine theta. Sine is radical 11 over 6. Cosine is negative 5 over 6. Multiply them together, and we're done. 20. You will not have a question that looks like that on the final. I will show you what your question will look like at the end. We didn't do that type of problem. The same goes, I believe, for 23. We'll see in a moment. Write the expression as the sine, cosine, or tangent of a single angle. So this is a backwards problem. So which identity looks like cosine times cosine minus sine times sine? Well, it's the sum formula for cosine. So that is going to be cosine of 5x. Simplify this. Your first step would be multiply by the conjugate to get your denominator to be 1 minus cosine squared, so you could get to sine squared. See, 23, not going to do that one either. 24, simplify as much as possible. So turn everything into sine and cosine. So we have cosine over sine over cosine. When you multiply by a fraction, or when you divide by a fraction, you multiply by the reciprocal. We happen to have a common denominator then. So we have cosine squared plus 1 over sine. What is the value of a given? Okay, so now we're into logs. So you could do a couple things. You could say, well, we know that when x equals 2, y equals 4. So a to what power is, if you multiply it by negative 2, you would get 4. And the answer you would get is 1/2. So you would have to see when x equals 2, y equals 4. So that means that 4 equals 1 over a squared. Multiply a squared by both sides, so 4a squared equals 1. Divide both sides by 4. Take the square root of both sides, it's 1/2. And that also would work for 0 and 1. Find the value of y equals log base 6 of 6 to the 1/3. Well, there's a couple different ways you could do this. You could raise both sides to the 6th power. You could also say, I would have said, y equals log base 6 of 6 to the 1/3, because that's what radical, the third root is. And then these would cancel, and y would just equal 1/3. If 81 equals 9 log x of 81, find the value of x. Well, there's a couple different things you could do there. If I want 81 to equal 81, I would say that log the x would have to be 9. Or you could say the base of the exponent becomes the base of the log, so 9, and then switch the other two. So then that would be 81 goes with the log instead of the by itself, and now by itself is the exponent. Well, if these have to equal each other, because those equal each other, x equals 9. This one has a typo in the solving of this. This should be 0.2 here, and since that's 0.2, that's not the right answer. It's negative 0.5, I think 117. Find the value of this, and I know most of you are just going to plug this into your calculators, and that's fine. But if you're not going to plug it into your calculator, you could say that the exponent goes back over here. Oop, it didn't draw. The exponent goes back over here. So that would be 5 log 5 of 7 squared. Those would cancel. And then 7 squared is 49. Right as a single log. Okay, so the number in front becomes the exponent again. The number in front becomes the exponent again. Addition becomes multiplication. And subtraction becomes division. Same thing here. Addition becomes multiplication. And subtraction becomes division. And that's reduced into a condensed form. The base of the log is the base of the exponent. Switch the other two. Done. Find the solution of that. So remember to check the solution. So addition becomes multiplication. And then we're going to rewrite this. We FOIL first. And then we rewrite this as the base of the log becomes the base of the exponent. Switch the other two. So we have 8 equals x squared minus 1. Add 1, take the square root of both sides, and we have x equals 3 and negative 3. Check the solutions in the original equation. You just want to make sure that you're not going to get a number that isn't possible. So I would check to make sure that both of those solutions work. Find the value of x. So addition becomes multiplication, and then we have natural log equals natural log, or just log equals log. Anytime a log equals another log, they cancel. Okay, so we have 3x equals 45. X plus 2, distribute the 45, solve for x. We get an ugly fraction, which you could check if you really wanted to. Okay, the value of your investment T years after 2005 is given by this exponential growth model. How much did you initially invest? Well, so we're trying to find A. How much did you initially invest? Well, in this type of problem, this is the initial investment. And that is the interest rate, which you can barely read there. So that is your answer right there. The value of your investment T years after 2005 is given by the exponential growth model here. When will your account be worth $6,000? So we're going to plug $6,000 into the end. You invested $5,000 at the beginning. And we're trying to find T. E is a number that you can press on your calculator. So we're going to divide both sides by 5,000. Divide both sides by 5,000. And we will get 6/5. To get rid of your E, you take the natural log of both sides, which again is a button on your calculator. And we will get the natural log of 6/5 equals 0.025 T. Plug all that in your calculator, and you will get 7.29 years. Next, I'm going to share the two problems to replace the ones that we got rid of.